So welcome to this class on Inferential Statistics. We will be learning about interval estimation today. So when we find two values using a simple statistics between which a population parameter lies, that is called interval estimation. So for example, if mu lies between A and B, that is the interval estimation for mu. Now what is a confidence interval? Confidence interval is a range of values derived from the sample statistic which is likely to contain the value of the population parameter. So the population parameter where it lies is called the confidence interval. So we have these confidence values. It's useful to remember this when we are doing problems. When we have a confidence level of 90%, alpha is 0.10, alpha by 2 is 0.05 and z alpha by 2 is 1.645. This is a normal distribution table. 95% it is 0.05 alpha by 2 is 0.025, z alpha by 2 is 1.96. Likewise for 99%, alpha is 0.01, alpha by 2 is 0.005 and z alpha by 2 is 2.576. So it's useful to remember the Central Limit Theorem, which says that the sampling distribution of the sample mean follows a normal distribution. That is a bell-shaped curve as the sample size gets larger. Now, confidence interval for mean mu. 95% confidence interval is x bar minus 1.96 sigma by root n, x bar plus 1.96 sigma by root n. When it is 99%, it is x bar plus or minus 2.58 sigma by root n. And when it is 90%, it is x bar plus or minus 1.645 sigma by root n. Let's start with problems. For a population consisting of 6 units, 1, 2, 3, 4, 5, 9, find 95% confidence interval for estimating the population mean mu. So x bar is 4 here, you can calculate, n is 5 and s is what's the formula we have learnt in the last session, square root of sigma xi minus x bar the whole squared by n minus 1. When you substitute you get 2 root 2. So point estimate for sigma is 2 root 2 and now we calculate 1.96 sigma by root n, that is 1.96 2 root 2 by root n. 1, 2, 3, 4, 5, 6, n is 6 here, not 5. And that will give you 2.263. So your 95% confidence interval will be 4, that is the x bar minus 1.96 sigma by root n, that is 4 minus 2.263, 4 plus 2.263 which is 1.74 and 6.26. Now coming to the next question. The mean and variance of a sample of 64 observations are 160 and 100 respectively. Calculate the 95% confidence limits for the population mean. In view of 95% confidence interval, if the error should not exceed plus or minus 1.4, how many additional observations are required? So n is 64 and what is x bar? It is 160, s squared is 100, so s is 10. And 95% confidence limit is given by the formula x bar minus 1.96 sigma by root n, x bar plus 1.96 sigma by root n. 1.96 sigma by root n will be 1.96 into 10 by root 64, which is 2.45. So your confidence interval will be 160 minus 2.45, 160 plus 2.45, which is 157.55 and 162.45. Now, coming back to the next question, the error should not exceed plus or minus 1.4. That means 1.96 sigma by root n should not exceed 1.4, or we'll keep it as 1.4. So 1.96 into 10 by root n is 1.4. So simplifying you get n equal to 196. So the additional observations required will be, totally you have how many observations? You have 64 observations and you'll need 196 observations. Coming to the next question. A person estimates the mean of the population by using a sufficiently large sample. The probability is 0.95 that the sample mean will not differ by the true mean by more than 50% of the standard deviation. How large should the sample size be? So we have 95% confidence interval. So what do we have? 1.96 sigma by root 10 becomes sigma by 2 because the sample mean should not differ by the true mean by more than 50% of the standard deviation. This is the error term. So simplifying, you get n equal to 15. The sigma gets cancelled and n equal to 15. Coming to the last question, the monthly sales of a shop are normally distributed with a standard deviation of rupees 900. A statistical study in the last 9 months has found a confidence interval for the mean of monthly sales with extremes of 4,663 and 5,839. What were the average sales over the 9-month period? And what is the confidence level for this interval? So sigma is 900 and we have x bar minus e, x bar plus e, that's the confidence intervals extremes are 4663 and 5839. So what is x bar minus e? 4663, x bar plus e is 5839. Simplifying, you get x bar is 5251 and e will be 588. But e is what? Z alpha by 2 sigma by root 10, the error term. And now you substitute for sigma and n. So you get Z alpha by 2 is 1.96 and we had already seen the values earlier. The confidence interval would be 95%. So we have learnt a basic idea of interval estimation in inferential statistics. My next class will teach about hypothesis testing and use of the t-table. Thank you.